All right, so welcome coders, welcome back. This is a lesson on data types and user input. We're going to talk all about the different types of data types, and we're going to talk about how to get your programs to actually take in user input. Should be a pretty good time. First thing you're going to want to do is you're going to want to open up Replit and go to our practice Replit, and we're going to look at how we can use data types with variables, what variables are, and how we can make those variables do different calculations based off of user input. All right, let's get into it. So here we have our Replit. Right now I have nothing put in. This is our first time working in our new Replit here. So we created a Replit, and over here we have our files. We can create a new file. I'm going to create one over here. I'm going to click on Add File here, and I'm going to call it Data Types. Now you'll notice that when I typed in data types, the beginning character that I put in is a lowercase letter, and the one that I put in over here is a capital letter, and I didn't put a space in there. They call this camel case, and a lot of times we're going to use camel case when we talk about putting words into variables. We're going to do that a little bit later, but just notice that I'm naming my files already. I'm starting with lowercase letters, and each new word that occurs after that, I'm going to make a capital letter. So let's start off with data types here. What we know so far is we know how to type in a command in the print function. So I could say the previous thing that we created was a hello world, which looks something like this. And then when we run it, it shows up over here as a screen. If it shows up here, what's going on here? This might not be, I need to rename it to a .py file, so that way it knows that it's a Python file. There we go. Now if I run it, it should run. We're already off to a great start here. I'm going to try this one more time. Okay, so we want data types, .py. I should be able to print, this plugin crashed. That might be why. Let's try this one more time. All right, so if we do print, and then in parentheses, we put hello world in here. What we're working with here is a string. When we press run here, it should show it over here on the right-hand side. It's because, okay. I'm going to work in the main.py file here. When we run a file inside of Replit, when we press run right here, it's actually going to run your main file here first, and then it will use these other files as necessary. So I'm going to start with just this main.py file here. I'm going to put everything in here, and I'm going to save our files as separate files here. When you press run on Replit, it's actually going to run your main.py file. So I'm going to put print here, and then the hello world. And when I press run, it's now going to run it from the main.py. And you'll see over here that it printed out that phrase that I put in here. Now, something very important to know. If you have just the print function right here, if you see something that has parentheses right after the word, then that is a function. I know for sure that this is a function. And what a function is simply a piece of code that runs multiple commands, usually multiple commands, a series of commands to simplify something. So if I were to tell you, or if your parents were to tell you to take out the trash, then you would know that there is a bunch of steps that are required in order to take out the trash. You would need to walk over to the trash bin. You'd have to open the trash can lid. You'd have to take the bag out of the trash. You'd have to sink the string on top of it, and so on and so forth. There's a bunch of steps to do that. And a function would be the shorthand name of those steps. So when we're making functions, you would make a function called take out the trash, and in that function, you would define all the steps that is taking out the trash, all the things you would have to do. That way, somebody could just say print something, and you wouldn't have to have all of the lingo inside or all the crazy complicated code that goes with those steps. You just have to say take out the trash or print. And that's what a function does. A function's giveaway is this double parentheses that you're going to see after a word is written. Now in this case, where I have print, I could write print and a number like 6. If I did that, it would run fine because it's printing an integer. Our first data type is going to be an integer. Now, before we actually get started, I want to show you that I can comment inside of here. If I put an octothorpe, or what some of you know as a hashtag or a pound sign, if I put that in here, then that means that the code is going to skip over that. So this is a comment. I'm going to actually change this back to hello world just so we can see that. There we go. All right, so if you have something in Replit, it'll look green. This is a comment. You make it with an octothorpe. And oftentimes we use this at the beginning of our program to write a little bit about what the program does. I'm going to write down my initials. I'm going to write down the date. That is it is August 30th here. Note that I'm going to write the date in year, month, day format. This is important because in computers, we want to get used to doing this. This makes everything work for us easier in the future. This format is very important to know. Year, month, day. We don't want to put day or month up here. It should be in this format. If you alphabetically organize something that is in this format, then it will sort properly. So that's why we use it. So now that I put my initials and the date, usually you're also going to put the name of what your program is. So this is going to be data types and user input. So what's cool about the comment is that the comment allows you to make notes for yourself or for other programmers who might be using your code. It's great to document as much as possible. The more vigilant you are in documenting everything that you do, the better of a programmer you will be, because more people are going to want to work with you, because it's obvious that the way that you think is going to be listed out in the program, instead of people having to guess and wonder, what is it that these functions do, or what does this program do? If you have it written out as comments, then it's going to make everybody's life easier. Even if you're working on a project by yourself and you're the only person that's going to touch it, there may be a time when you program something and then 5 years later you're going to have to go back to that program and do something to it or add it to another program. And if you didn't document it, you will be kicking yourself. So even if you're the only person working on it, make sure you document your own code, because it will help future you. All right, that said, this is only one type of comment. There's another type of comment in Python, which is the multi-line comment. It's a little bit different from the single-line comment. It's 3 single quotes. If you put 3 single quotes down, then anything that you write in between those series of quotes becomes a comment as well. So this is good to know. Typically, in this class, we're only really going to be using the octothorpe single-line comments, though. You can put single-line comments as the entire line of code, as you see here, or you can put a single-line comment on another line that is already occupied by code, like this. You can put it on the comments right next to lines too. So you could say that a comment for this little print hello world, you could put that comment right here next to it. So it doesn't have to be on its own line. You can put it in conjunction next to other code. All right. So now that we know how to comment and we know how to do our basic print command, let's talk a little bit about variables. So with variables, we can do an assignment to variables. The easiest way to think about variables are that they are containers. They're buckets in your RAM warehouse that are labeled and have some kind of content or a value. They call them values. A value is simply some type of information that is stored in the bucket. So you can think about any kind of variable is like a container or a bucket in a big warehouse that is your RAM, and it's labeled. The label is what name you give it, and the value is what actual contents it has in the bucket. And there's different types of values. Those values are going to be our data types. Now, if we go forward, let's see how we can actually make an example of this. Let's say I wanted to make this this message, hello world. Let's say I wanted to save this, or I wanted to make a message. To create a variable, all you got to do is type the name of the variable that you want. So I'm just going to type message, and then you type a single equal sign. Now, it's very important. We're going to learn that there are two different types of equal signs in programming that are commonly used. The single sign that you see here, this is known as an assignment operator. When you see it as a programmer, you don't see an equal sign like you would in math. If you see a single equal sign, that means it's an assignment operator. And that means I'm giving this name right here is the label that I'm going to give to a variable or a bucket in my RAM warehouse. So what is that message going to be? I'm going to make it in double quotes. Welcome to McDowell's class. As you can see here, I have it in double quotes. And when I have something in double or single quotes, that makes it a string. So I'm going to put this. I'm going to just put a little comment here that says string. And then I'm going to say it is held in double or single quotes around outside. And what does it do exactly? Well, it's just saving each ASCII character in a sequence. So strings are actually related to another data type, which isn't used very often, but I'm going to mention it. Characters. And characters are simply ASCII characters that are basically 8-bit codes, 8-bit binary codes to represent some kind of letter that you're used to in the English language. So they're usually 8-bit. I'll put that there. So characters are an important thing. A character example would be, if I wanted to make a example of that, I'm going to make a variable called char, and I'm just going to make it a single character, M. There we go. So this would be an example of a character variable. This message right here is an example of a string. So I'm going to take this and just put it down here so you can see that they're there. You might want to get used to organizing and being able to move around in code. You're going to notice that when I move around, there's a few different ways that you can interact with the Replit code interface here. You're going to notice every line of code is numbered. If I wanted to select everything in a line, I could just click on the line of it here, and that would allow me to select it. So this is very useful if I wanted to copy and paste and reorder and move stuff around. I could simply click on it. However, to be honest with you, most programmers don't use their mouse very much. So what you're going to do more often is going to be you're going to use your keyboard to do this. If you hold down the Shift key and then you press the down arrow, wherever you are, it's going to select the code below or above that. So this is a good way for you to select multiple lines of code. If I wanted to copy and paste this whole section, I could go to the beginning of it, hold down Shift, and select whatever I want, then copy and paste somewhere else. So you can get kind of used to moving around with just the keyboard here in the Replit section. Moving around things is usually pretty easy if you use the Shift key to be able to select whole lines. This is really useful to be able to move stuff around. All right, so let's talk about what a string is. A string is just a series of characters, and they're all concatenated into each other. So we have the W ASCII character followed by an E and followed by an L and so on and so forth. You could think of it as a long list of just characters, and that would be a string. If I wanted to print out this string right here, I could put this whole message in like this and copy it and put print, and then in parentheses I could put that message, and that would work fine. If we see that printed here, if I run that code, you'll see it says hello world because it's printing hello world up here. And then it says welcome to McDowell's class. If I took this print out and I just ran it, you would see only the hello world here because it's only printing that command. I did save this message as welcome to McDowell's class, but I didn't actually have it displayed anywhere in the program. It is saved in RAM, so it can be used later, but it isn't actually being displayed. If I want to display it, I could type in print and then write the shorthand of the thing that I wanted to display. Now you'll notice I did not put quotes around this. If it's a variable name, you don't want to put quotes around it, because if I put quotes around it, then it knows that I'm trying to say that this is the ASCII character lower m, followed by lowercase e, and so on and so forth. If I don't put those quotes around the outside, then the computer knows that I'm talking about an actual variable. I'm asking for something that's already stored in memory. So right here, if I put print message, you'll notice there's no quotes around it, then it's going to print out what is contained in the message memory location, which is this string right here. Let's go ahead and run it. There we go. So you can see that it prints out the same thing. What I could do is I could copy and paste this if I wanted to, and you'll see that it will print multiple versions of that same thing. So if I wanted to print it 3 times, there we go. All I have to do is have it print the variable container here, and whatever is in here will change, or whatever's in here will be printed out. All right, so now we know how to print out variables that we create. Let's talk about the different types of variables beyond this. Beyond the string, there are number variables. In Python, lucky for you, there's only one real number type, but in most computer languages, they're going to have differentiations between different data types. There's the integer type, there's the float type, and there's the double type, which is what you'll mostly see in programming languages. Let's start off with just integers. Integers are fairly easy. You'll see int, which equals integer. And integers are just whole numbers. What does that mean? Well, that means there's no decimals, no decimal points involved. So an example would be like the number 5 or 13. If I wanted to save a number, I'm gonna call it int number 1. We'll just say that, int number, and I'm gonna call this just 5. There we go. And if I wanted to print that int number, then we should see that it will print out 5 over here after it does the Welcome to McDowell's class over here. So there we go. I've got 5 here. By the way, if I wanted to make it to where it doesn't show all this code that I wrote up here before, I could do what is known as commenting it out. You're going to hear this all the time. Hey, I wrote this new code, but it's not totally ready yet, so I commented it out. What that means is we can use a multi-line comment to just comment all of this stuff out. If I wanted to make it to where only a certain section of it ran, I could go in here. I could add that triple single quote to begin my commenting. And then down here, I could put my triple line comment. And now all the stuff in between there is commented out, so it's not going to run. It's going to basically skip over all this stuff and go down to after that comment. So now if I press run, what do you know? It will only show that last part down here where it says int number 5. Cool. So if you ever hear the term commenting something out, that's what it's from. You're simply commenting out code that would normally run, so that way the thing that you're running just shows up and not all the stuff that we ran before. So a very useful thing to know how to do is commenting out lines of code with multiple line comments. So I'll just leave that up there for now. All right, so we know what integers are. Pretty simple. They're just numbers without decimal points. There's another type of number, and that is called the float. And this is what most of the time you'll deal with. Something to note about floats is that they take up well, first of all, they're decimal numbers. Decimal point numbers. So that means that they have a decimal point. An example of that, float number. An example, a very famous one would be 3.14. That would be the quintessential float number to remember, floating pi. And as an octothorpe, I'm going to list out the main difference that you're going to need to know as a programmer between these two things is that integers are good for quick, fast math. Floats are good for really precise decimal math, but also integers take up less space. They take up less processing power. In RAM, integers don't take up as many buckets, if you want to think of it that way. So using an integer is useful because it takes up a small amount of RAM. And floating point numbers take up more RAM. Now, for most of our purposes in this class, this won't be a huge, big distinction and it won't matter that much. But when you get into really big programs where they do a lot of calculations, there's a lot of things going on at once, especially multiplayer games that have to take into account a lot of different trajectories of projectiles and things like that. then every little bit of RAM that you can squeeze out, every little bit of performance that you use is important. Thus, choosing the right variable type does make a difference. Choosing the right kind of number type will make a difference for you. It's just something to be known. In Python, lucky you, it makes every number appropriate to the situation. So if you don't put a decimal point, it's going to save it as an integer, basically, in the amount of space that it uses. And if it needs to use a float, then it will add the appropriate amount of RAM that needs to be used to make it work. So for Python, hey, it's real nice to us. We don't have to know anything other than that's just a number variable type. But for other programming languages, there is a big difference between these two variable types. So I just wanted to make sure that everybody's aware of that when we first start here. If I wanted to have this print out this floating number, I could just type in print. And what you're going to notice is, as we go along, there's something called autofill. Let me show you how that works in just a moment here. So I'm going to run this just so you can see. It's going to print out both of the numbers now. The same method is used. We have our variable declaration. We have our assignment operator, and then we have the value that we want to be held inside of that variable. After that, we have our print function, which prints whatever we have here, and if we have a variable in here, it will print that out. Now, what happens if I have, let me take these quotes out here. I'm going to show you what happens if I have a char and I try to print that with a float or one of these numbers right here. So I want it to print out M, and I want it to print out 5 right next to each other. If I do print, I got an admirer over here. All right, if I do print and I do char, and what comes out? Well, M's going to come out. That's good. What if I do char plus int number? I have got a problem. The problem is, it says you get a traceback error. Anytime you have a problem, it's going to basically spit out an error to you, and it's going to be this red text right here. The main things to look for, right here, it's going to tell you where the problem is. It says it's in the file main.py, which is the thing that we're working in, and it says that the problem is on line 31. And that means that I could actually, if I look at the lines here of all the different numbers that are listed, I can go down and I know, oh, it's line 31. Here's the problem right here. Now, for our program right now, it's not that big of a deal, but if you work in a big studio, there could be thousands of lines of code. So when you're debugging, it's really helpful that the debugger tells us where the issue is. After that, it'll say what the type of the error is. Now, if you are in a situation where I have no idea what this means, it's just gibberish gobbledygook, guess what you can do? That's right. You can select it and just pump it into Google. Whoops. There we go. I'm going to take this. I'm going to copy it. I'm just going to paste it in here. And what's nice is you're going to see that there's all the time you're going to see that there is somebody looking for that exact error message for you. So don't worry. All this stuff has happened before. It can only concatenate string. I want to take all this out. If I search for the exact error message, you're often going to find something that tells you exactly what the problem is. So right here, usually you can go to the very first thing, and it will give you a little explanation of what the problem is. In this case, I can tell you what the problem is. The string and the integer does not play well together. They are two fundamentally different things. One is a bunch of ASCII characters, and numbers are thought of as actual values, like they have a numeric purpose, versus characters and strings, which are just to look a certain way. So they don't really play well together. You'll see right here what it's actually trying to say is you're trying to concatenate, which is concatenation is when we add a string to another string. Let me show you what that looks like real quick. If we have these strings, I'm going to go up to the strings section here. I'm going to show you how to concatenate strings real quick. Concatenation is a fancy word. It's a long word there, concatenation. But it basically means adding strings together. That's all it really is. Concatenation is adding strings together. And you'll notice that That word is used over here. It can only concatenate strings, not integers. So you can't add integers to other integers the way that strings add together. When you add strings together, it looks like this. So I have this char variable here, and I have a message variable here. If I wanted to put them together, I could do that like this. I would type in print. I'd type in char as my first character, or my first variable. The concatenation operator is the plus sign. So just like we did before, where we looked at the equal sign, and we thought, okay, that's the equal sign, but in programming, it's called the assignment operator. In programming, the plus inside of this section is called the concatenation operator. And basically, if I add the char to the message, like this, it's going to take this variable and append it or add it to the beginning of this one. So it's going to show this variable first as an ASCII character set, and then it will show this one. So when I press run, you're going to see during that section of code, let me comment this out real quick because it's giving us an error. There we go. If I run this, then you're going to see that it's going to, right here, it combined those two strings together. It took the char variable and it put the message variable right after it, or it concatenated them. Basically, you're adding strings together. You can do this with strings that aren't made as variables as well. If I wanted to, I could type in specific ASCII characters. So I'm going to put con, use a concatenation operator, make a new string, make a new string, 10, and one more, 8. There we go. So if I wanted to print out this series of string, plus this one, plus this one, plus this one. When you add strings together, really you're just laying them one right after another. So you can see here when it actually says it, it puts out the whole word. Now if you want to have spaces and what have you, remember spaces are ASCII characters. The computer doesn't know that anything about the English language or anything. It just knows which characters you want displayed. So if I wanted spaces in between some words, like if I wanted to put my name starts with a. If I just left it like that and I put a concatenation and then the char right there, you'll notice that when I run it, it really doesn't put a space or anything in between. It just straight up says exactly what you put right after here. So if I wanted this to have a space in between the A and the M right there, I would have to put it here where there's that space there, and then it will concatenate the char after that. So it's an important thing to note. When you concatenate, it really just smashes the ASCII characters right next to each other. There's no spacing. Now that said, there is one other thing you can do with the print command. You can actually list out the things that you want to print in a list. So to do this, if I wanted to, I could put char and then put a comma and then put my message. And if I do that, then it's going to list out the value of char, and then it's going to separately print out the message that's listed here. And it's going to put a space in between them. This is an important thing. When you use a list inside of a print command like this, if I put one variable then another, it will put spaces in between them. So if I run this, you're going to see that it types the M from char, then it puts a space, and then it puts this. And this is important because of this version. If I put a number right here where I have a concatenation with a string, then that's going to work fine. If I put a number here, though, my name starts with a, let's just say I put 13 here, I'll get an error, as we saw before. Same thing, you can't concatenate an integer with a string. So what I'm going to do is, instead, I'm going to put, instead of a plus here, I'm going to put a comma. And what's happening is I'm not concatenating a string with this. I'm simply listing this out first. Then it's going to put a space, and then it's going to list out what this is. Even if these data types do not match, even if this is a string and this is a number, it will still print them out properly. So if I run this, you'll see that now we have my name starts with a, and then right here it puts a space and the 13. So if you need to have a mixed variable display with print, you're going to have to use the comma here. So basically, you can write out your string, and then comma, and then your number afterwards. All right, so now we know how to print out messages, mixed variable messages. We know about strings. We know about numbers, the types of number variables that there are. There's also a important variable, which is the Boolean variable. Let's talk about that. Boolean variables are all about logic. There's a guy that made these, George Boole. You'll learn about him. He's an interesting character. But Boolean logic is very simple. It's either true or false. That's all you got to know. Something is either there or not. It's binary in a sense. It's 1 or a 0. It's a true or a false. And Boolean logic is usually represented with these 3 types. There's and, not, and or. We're going to talk about these Boolean operators a little bit later. Boolean variables are always true or false. And the operators are and, not, and or. We'll talk about those operators later. But basically, we can go through all of the different types of logic with these ideas. For example, let's say I wanted to throw a party for somebody if it is their birthday, right? If it is their birthday, then I'll give them a party. Oh, but let's say they also have to be present in class. If I wanted to make a program that made it to where if it's your birthday and you're in class, if that is true, then run something. That's how we get all of the logic out of computers. It's all these simple ideas of is something true or false? And then we can add conditions like if this and this is true, then do this. Or if this is true but not this, do that. Or you can make it if you are here or it's your birthday, then I'll give you a high five. I could do that as well. So there's different ways that we can use these Boolean logics to make decisions. This is how all computers make decisions. But the main thing to know when it comes to just variables, Boolean variables are always true or false. So if I wanted to say, usually you're going to see Boolean variables with the prefix of is. So in this case, I could put is awake equals true. And you'll see that that is a Boolean variable that's simply saying that I am awake, I guess, or the program is awake. Usually you're going to put is and something is looking forward to weekend equals true. There we go. So these are some different ways that you can name your variables. You'll notice that the naming of variables, as I talked before about the whole lowercase letter at the beginning and then a uppercase letter after that, if you have multiple words for your variables, usually variables, just as a matter of convention, usually variables have a lowercase letter when they start, and they have an uppercase letter whenever you have a new word. This makes it easier for you to be able to read something. Alternatively, you could use underscores if you want to. You just can't use spaces. If you use spaces, it breaks up your code and it doesn't work right. So if you need to use a space to be able to name something in a variable name, make sure that you use that underscore. Also, there's some special variables that use an underscore at the beginning of the sentence or of the variable name, but we'll get to those eventually. All you have to know for now is that camel case is a way to make code easier to read, because usually we make the first letter of our variables a lowercase letter. These are just conventions. The computer doesn't really care. It will run fine. But as you work with other programmers, you're going to see that there's just a natural way or a agreed upon syntax for us to do everything the same way. Right now, though, you can just see that we have some Boolean values. There's the true one here, and then there's also false. There's something to note, though. If I make a Boolean value and I make it lowercase true, it doesn't work. The thing about Boolean values, the way that Python knows that it's a Boolean value is that it's capitalized. So you have to have a capital T for your true to make it a Boolean value. If I made this false all in lowercase, it doesn't know that that's Boolean false. It just thinks that that's a bunch of characters. If I type in a capital F, then you'll notice it turns blue. Now it knows that that is a Boolean value that is going to be stored in memory. All right, so now we know about numbers, we know about floats, we know about Booleans. Let's talk a little bit about naming conventions. Variable names, they can only have letters, numbers, and underscores. You can start with a letter or an underscore, but you can't start with a number. So if I wanted to do this, if I wanted to do 1 Boolean equals true, this is not a good naming convention. Anything that has a number at the beginning, you don't want that. You would rather have the number afterwards. You don't want to start your variables with a number typically. Also, spaces aren't allowed in variable names, but you can use underscores. And also, you should make your variable name short but descriptive. So right here is looking forward to weekend. That could work, but you typically want to make it as short as possible. In fact, a lot of programmers, unfortunately, they'll make things like this: x equals 10, y equals 50, z equals 3. And then they're going to do some calculations with this. These variables will technically work. The computer won't know any difference. But unless you know exactly what x and y and z are just intrinsically from looking at your program, it will be very difficult for you to use. So sometimes people will do this because as programmers, we're all efficient. We're efficient. So we want to type as little as possible. So I understand making really short variables, but oftentimes you want to make them descriptive to where you know that they somehow have to do with a concept. Whatever kind of thing you're making, you want to make these names very descriptive, not just single letter variables if possible. All right, so let's talk a little bit about strings here. We talked about concatenation a little bit. I'm going to walk through just a few things real quick so we can see that there are other things that we can do with strings. So I'm going to go back up to where our string section is. We talked about concatenation, so I'm going to just print a concatenation here. Let's talk about somebody that we have learned about. I'm going to put a name here. I'm going to put name equals Ada Lovelace. I'm going to put it all in lowercase. So here I have the name. What's cool is there are some functions that we can put in into the print command that run inside. So in these parentheses right here, I could put a function inside of there. And what I'm going to do is I'm going to type name.title. Now, this is called a method, and we're going to talk all about methods in the future. But all you got to know is if you have a variable like this, you can do stuff to that variable string outside of working with the declaration of the variable here. So right here, I could just put print name. Let's see what that would do. If I put just print name in this section, I'm going to comment all the rest of this code. Actually, yeah, there we go. If I just put print name right here, then in that code, you're going to see it says Ada Lovelace. Let me comment these other things out just so we can see very clearly what's going on. I'm going to take this out. Put my double strings here. There we go. I'm just going to comment all the rest of the code out so that way you don't have to worry about it. We'll go back to it later. But here we go. I've got just this line of code, 21 through 23, active. If I press run, you'll see it just prints out Ada Lovelace. Cool. But what we can do is we can add modifiers to a variable. So right here, this string name right here, I could put name.title. Now, whenever you use a dot, that means that you're affecting the thing that the variable name that's before that dot. That's what you're affecting. You're manipulating this variable somehow. And what are you doing to it? You're running another function. Remember, functions are something that have little parentheses after them. So right here, this function is the title function. And what does it do? Let's find out when I press run. It appears that the title function will take the first character of any word or any string that is a word separated by a space, and it will capitalize the first letter of it. Okay. So if somebody typed in their name in all lowercase, I can make it to where automatically the computer will capitalize the first letter of their names. Excellent. That's the title command. Let's see what else we can do with this. If I type in print in parentheses, I'm going to do name dot upper. The upper method will print out everything in uppercase ASCII characters instead of a mixture of the two. And here we have lower. Now you're going to notice something that is confusing to most initial programmers, and that is, let's take a look at this really closely here. When I say print, let me just put the regular print name up here too so we can look at the difference. If I put print and name, then that means anything that's inside of these parentheses is what it's going to print. Now you're going to notice right here it looks pretty ghastly because it's got all these parentheses over here on the far right. You just have to know that even if you have your function inside of another function's parameter list, you still have to add these little parentheses over here. So many of you are going to run into problems where you're going to forget a parentheses set or something like that inside of another parentheses set. This is just something that you're going to have to get used to thinking about when you see a function. Inside that parentheses over here of that function, that is the value that's passed into the function. So this is like the input, if you want to think of it that way. Now, not every function needs input. Like this title one, it just knows that there's no modifier to it. It's just going to make every first character into a capital letter. So if we run this, we're going to see that it takes that same one single variable, but it's able to show it in different ways. There's all lowercase or unaffected in this case. There's the title version where I ran the title function on that variable, and that makes it capital A and capital L. Then the name.upper, this makes it all uppercase, and there's all lowercase. Now, at first, it might seem like these aren't very useful, but actually, these are incredibly useful commands, and so we're going to be using them quite a bit. Now, if we wanted to concatenate this, we could say name, and then we could add something to it. So I'm just going to show you that concatenation right here. Actually, let me label each one of these too. So this function right here makes first letters of words uppercase. This one makes all characters uppercase. And I'm just going to take this. A lot of the people that I used to program with, we would have we would have competitions to see who had to touch their mouse first when we would code. So get used to seeing how I'm doing things up here. You're going to see how to do things with just the keyboard. I try to use the mouse as little as possible, so you're going to see a lot of times I'll copy and paste things and just move the characters around. That is because I'm consciously trying to not use the mouse, just in case you're wondering why I do things like that. All right, so this is how you can do these different comments. Let's talk about the concatenation operator. So if I wanted to put print and then I want name, I could put another string after that, was the first computer programmer. If I print this out, you're going to see that it puts the name, and it's going to append that string to the beginning of this string. And notice that I put a space right here at the beginning there. I could do that. I could also, as you already know, I could not concatenate it this way. I could concatenate it, or I could list them as a list. And if I do that, I would put a comment or a comma here instead, and then I wouldn't need that space because it's going to add a space when I list things out as a list. So I'm going to run this, and you'll see, they work the same way, but this one concatenates the strings together, and this one simply lists them one after each other with a space. The big thing is that this one, when you list it out, you can mix variable types. You can show numbers and strings. But if you use this type, you can only concatenate strings with more strings. So that's an important distinction to know. I'll list that right here as well. So it's going to be concatenating. And this would be listing. All right, so there we go. We've got a pretty nice list of variables here. Now we can actually use this to be able to make all kinds of programs. We could have it ask you for your name, for example. Let's talk a little bit about user input. User input is going to be important for us to be able to create our next program, the program that you have in your assignment here. So let's talk about that. User input, pretty simple. You've got two things to know how to do. One is simply the input command. The input command waits for you to actually write something. So I'm going to comment out the rest of my code here just so I can show this one code right here. So we've got just user input. If I typed in input in the parentheses here, if I run this, it's just waiting for me to type something. And I could type that. If I press enter, then the program is done with. All it's doing is waiting for me to type something in. It doesn't actually store it at this point. This is just giving me the time to be able to sit and write something. So I could put something before this, like hello, type something please, and then after that I could have it print out thank you. And you're going to see that it's going to type out hello, type something please, and then it's going to wait for me to type something. I could type something, I press enter, and then it will move on to the next line of code. Thank you. All right, now what I could do is I could save this input as something else. You see me just after class maybe? Sorry. All right, so I have this input right here. I have hello, type something please. What I could do is I could have this input saved as something. So I'm gonna put right before input here, I'm gonna put saved response, or I'll just put response. Response equals input. And now I can have it print that same variable out down below. So I'm going to do that right here. I'm going to say print you wrote down. And I'm going to put a comma, just in case they write a number instead of a string thing. I'm going to put you wrote down, and I'm going to put a comma here. Now I could just put a plus. In fact, let's just do that so we can see how that would be, what the difference would be. I have you wrote down and then plus response. I'll even put a little space here so there's a little bit of time. Let's see what this looks like. So if I run it, it says, hello, type something please. I typed something in, and now it says, thank you, you wrote down, and it displayed the name of that variable that was saved. So now we know how to take input and save it to a variable, and then we can place that variable somewhere else in the code. Now, something very important when it comes to variables, your variable has to be declared or created before you decide to actually print it out somewhere. So if I put you wrote down response, if I put this before I actually created the response, okay, if I needed to show that there was a response and I put the variable before it was even declared, you'll get an error, and it'll say the name is not defined. So basically that means you need to declare what response means, or what is inside of response before you have it shown. It makes sense, but if you're not thinking, if you're in programming mode and you're not thinking about it entirely, this can be something that you run into that's confusing. So now we know how to get a user input. Let's see that there is actually a more efficient way to do this, though. Right here where it says input and it has the parentheses, we want to take this string, this hello, type something please. I'm going to put this in those parentheses. The cool thing about the input command is that this is actually asked as a question or a prompt. So if I had just input and I had a question right here, this is the question it would ask for that response, or for that question of the input right here. So if I run this, we're going to see it asks me to type something please. I type something in, I press enter, and there it saved what I typed in and it replied. So you can create an input in a few ways. You can make it to where you don't have anything in the parameter list, and then it just waits for you to type something in. And then you could put in a prompt inside of this list. Question goes here. So if we have it that way, then it'll ask you the question, and you can type it in. Now, one important thing, this looks kind of janky. If I were to type this, it's right there next to the this string, and it doesn't look very good. You can skip down lines if you use the /n command. So /n, if you put that into a string, that's a new line break. The computer reads that as I want to put an enter key, basically, the same thing as skipping down a line. So if I put that here, now when I run this, it'll say question goes here. It gives me a little time. I could type something in, and there we still have the response loaded up. So this should be all you need in order to complete the first project. You need to be able to create an input. You need to be able to have it put out an output. Let's take a look at the assignment for this assignment here. So we're going to go into our classroom. In our classroom, you'll see that there are 2 assignments so far. There's the Hello World assignment. Make sure that you submit that. And then there's the user input. So let's take a look at this assignment. It looks something like this. Andy's already completed it, I think. Good job. Basically, you're going to create a program that asks the user, what is your name? It's going to save the user's input, whatever they type in. And then it's going to send back the message, hello, and their name, and an exclamation mark after their name into the console. Very important to think of this when you start looking at strings. Remember, the name is going to be its own variable, or it's going to be concatenated. You're going to have the hello, and you're going to have the exclamation mark. Don't forget, and when it comes to strings, it is a very specific ASCII character. If it tells you there's something wrong, it could be that you're forgetting something that's listed in here. That said, everything is more or less listed out here. You'll notice I put the question as a print here, and then I put an input here. You could put the question in here and take this out. That's another way to do this. I just listed out one way for you to be able to complete a project. Just so you know how these Replit assignments are graded, they're auto-graded. So you have to put in the right thing exactly in order for it to come out exactly right. That said, the output is what is graded, not the input. You could have your program ask, for example, what is the user's name instead of what is your name. The input part of it doesn't matter character for character. The output is what matters. So what comes out at the very end of your program, that is what will be graded. So there's different ways of getting the answer at the end to come out right. So that part isn't graded. The way that you structure your code isn't. But what actually comes out as the final answer is graded. If you come out with the wrong answer, it'll tell you that there's an error and it'll list a reason why. You'll just have to go in and debug and find out why that is. All right, that's pretty much it that I had for today. I hope you understand how variables work. We learned about concatenating strings. So let me put this back up here. We learned all about the different data types, Boolean values. We learned about strings. We learned about characters. We learned how to concatenate. We learned how to put in user input. We learned about Boolean variables. There is one last thing that I would like to talk about, and that is white space. White space is basically what we saw about being able to add a new line right here. That would be white space. In fact, let me write that up here above the user input here. We'll talk about white space. So white space is basically having additional things added, so or additional space that is listed. So white space is very important in Python. We're going to talk about why, but if I just type in print Python here, and then I do print /t Python. /t is for tabbing. Let me just comment this out here so you don't see it. There we go. So I have just this code right here that's going to be running. If I run it, you're going to see it says Python. /t is to put a tab in. So you know how to make tabs now. It's just the /t command. /n is for making a new line. So if I did p/n, y/n, t/n, h/n, o/n, n/n, exclamation mark. It looks like just a weird, really horrible jumble here, but when we print that out, there we go. We've got the word Python in it. So you can see that there are different ways that you can use white space with these little / characters. They're usually called special characters or command characters. I'll list them out right here so you can see. This one is for tabs, inserts a tab. This one right here will insert a new line. /n is a new line. All right. When it comes to white space, there are ways that you can strip white space, which is really nice. In case there's extra spaces and stuff like that, there are some commands you can use for that. What's your instructor? Just write it down. I'll email her after class.
It's Mr. J for 180
Mr. J, do you know his name?
It's like Mr. Draw. No, I don't.
If you can find out his name, I'll email him.
Sure.
Yeah.
I'll be back.
Okay. All right, so when it comes to white space, we can also strip out white space. So to us, if I were to print out a string, let's say I make a string, let's say, I will say name equals, if I put my name in, but I put a space after it right here, then that means that there's actually white space. There is an ASCII space in here, and sometimes maybe even people will put a bunch of spaces after. What this would make it seem to the computer is that there is a bunch of extra saved information, and it might affect the program that I use in the future. So we have some methods that we can use to be able to strip out that extra space. If I did print name is teaching you. If I run this, you're going to see that now name, there's a whole bunch of spaces. So even though I put my name, I put a whole bunch of spaces in, and then there's an extra space there. What I could do is I could do name, and I can actually strip out the white space if I go dot strip or dot rstrip. Rstrip is going to strip out everything to the right, and lstrip will strip out everything to the left. So if I press that and run it, you'll notice that it stripped out all of the empty space to the right of my variable. If I did lstrip, then it would take out everything before it. So let me add some spaces to this just so you can see. If I put my name in between a bunch of spaces, if I ran this, it's going to strip out the right side strip with this. So you can see this is good, but I got a bunch of space on the side. If I made this instead left strip, I'm just going to copy this and paste it. If I'd made it lstrip instead, then you're going to see that it takes all the stuff off of the left side. So this is how we can strip out white space on the left or right sides. Also, you can just go straight up strip. If you want to be a programmer stripper, you can do that right here, and it will take out the white space on both sides of the variable. So very useful to know how to do. Stripping out white space is something that is pretty common, especially if you're dealing with users that are typing in stuff. Humans have a great way of trying to find errors in any kind of computer program, so being able to find out white space and take that out is something that is very useful. All right, so that's all I'm going to cover for today. We talked about white space, we talked about concatenation, we talked about strings, we talked about Boolean, and we talked about how we can get things to print out with a list as well. I hope you enjoyed this lesson, and I look forward to seeing you again soon.